Good afternoon and welcome to ARPAS UK's CPD session. This afternoon's subject and our speaker is Distant Clouds, Drone Flying on a Remote UK Overseas Territory. This is being presented by Ben Sansom at Arctium. Ben is going to give us a talk on the use of drones on St Helena and how they're being used to make decisions and save the island's unique habitat, a really crucial point in our Earth's and our planet's conservation. Ben is a water resource consultant with over 25 years experience and has been using drones for environmental projects since 2016. He's currently working in Kenya, Barbuda and St Helena with colleagues from the RSPB, the UK Met Office, the UK Centre for Ecology and Hydrology, the FCDO, which is the Foreign and Commonwealth Development Office, and the governments of St Helena and Antigua and Barbuda. And I think this is going to be a really interesting discussion and presentation. So I'm going to hand over to you now, Ben. I'm going to turn my own camera and microphone off so that we're not disturbed at all at this end. Thank you very much. Over to you.
Thank you very much, Helena. I will just share my screen. Hopefully this should all work seamlessly. Right, here we go. And right, hopefully everybody can see the slides, which would be great. So yes, as Helena said, I've been very fortunate to have worked on several small islands around the world now and in locations that are pretty remote to work into, and the one that's the most remote has been St Helena, and I've had an amazing experience working with a group of really wonderful people over the last 10 years on the islands, where I started out running the St Helena government's environment department, and then when that piece of work finished, I then have been working on some water and environment research projects on the island since end of 2015, early 2016, through to now. So I think before we start the slideshow in earnest, I will hopefully, there we go. I'd just like to introduce a lot of the project partners here. We have, as Helena said, so the projects I'm working with a number of amazing organisations such as St Helena Government, Connect St Helena, Met Office, Q, and St Helena Research Institute, amongst others. And I should also say a big thanks to the UK government, who have a couple of different funding streams that have been supporting the research we've been doing, looking at the island's habitats and water resources. The first one is the Darwin Plus initiative. Darwin Plus is an environmental and conservation fund, which enables the UK's overseas territories to basically submit project ideas and to apply for a grant to actually put those environmental research projects into practice. And some of the things I should talk about today are related to two Darwin Plus funded projects, one which has looked at linking the relationship between the cloud forest and its function for providing the island's water supply, and the other one for producing a new monitoring network so that the island is more resilient for understanding the impacts of climate change and looking at drought warning, as the island has experienced several droughts over the last few years. And the final project is the one that's being funded by the Foreign Commonwealth and Development Office of the UK government, and that is a 4-year cloud forest restoration project. I should also say, as a final thanks before we start, very big thanks to Bruce Dancy at Air Safety Support International and to Gwyneth Howell at St Helena Airport, who have both been amazing in helping us get the drone use on the island off the ground, and just to help us work through all the requirements for training, legislative compliance, and all the other things that we have to do in between. So first thing first is, where is St Helena? As you can see, the red pin shows that the island is right in the middle of the South Atlantic. It's a very, very tiny place. It's about the size of Jersey. It's one of the remotest settled islands in the world, and it's got a population of 4,500 people. The nearest habitable land to St Helena is the island of Ascension, and that is another UK overseas territory. And that's 703 miles northwest of St Helena. St Helena itself is 1,200 miles off the southwest coast of Africa. It's 47 square miles in size, and as you can see, it's around 10.5 miles long and 6.5 miles wide. The island's unique in that it's a seamount. So it was created millions of years ago from a hotspot close to the mid-Atlantic ridge. That hot plume of magma broke through the Earth's crust and created the seamount, and the island that you can see at the surface, a bit like an iceberg, it's only a tiny proportion of the total mass of the seamount itself. The island's history is really, really interesting. Some of you may be familiar with Napoleon's exile on St Helena. We're going back a few more centuries. The island was discovered in May 1502 on the feast of St Helena by the Portuguese explorer João de Nova Castella. It was used by the Portuguese for several years to provide fresh water, timber, and food for the spice trade. So when ships were going from Asia around the Cape and up into Europe, they'd stop off at St Helena, take on board more fresh water. Citrus fruit were planted on the island to obviously allow the sailors to combat the impacts of scurvy as they went through, and also goats and pigs were left on the island, so there was a source of meat. But when the island was discovered, as I said, it was completely uninhabited. The British then went and discovered the island in 1588, and we basically took it off the Portuguese, and it was settled by the East India Company. However, there was a brief occupation by the Dutch between 1672 and 1673. But after that, the island remained in the hands of the East India Company before it's been transferred as a crown colony to the British government. And in October 1815, Napoleon was exiled for six years on the island until his demise. Over the island's history, it has been used as a hub for the slave trade. A very sad part of the island's history, and it was used as a sort of a midpoint between the African nations and the Americas. And it was also more recently used as part of the flax industry for harvesting the flax fibers, and they were used for making, in principle, things like postal bags that used to be made out of the flax. The island is a UK dependency, and it's one of the 16 UK overseas territories. The reason that we've been working on the island and why it's so valuable is that out of all of the UK overseas territories, the island has an incredibly unique fauna and flora, and it has over 400 endemic invertebrates, more than on all of the other overseas territories and the UK combined. But it also holds a third of all of the total endemic species, that's plant species and invertebrates. So it's a very special place. It might be very small, but it has a big impact. Habitat management has a big impact on how the UK can manage the endemic species that it is responsible for. So this is a little slide that gives you an idea of the center of the island. The island has a montane cloud forest, and it principally comprises of a tree fern. And there are a lot of other endemic plant species that grow within there. As I said before, when the Portuguese found the island, they placed pigs and goats on the island. And unfortunately, since then, due to human habitation, a lot of the island's forest area was destroyed through grazing, clearing for property development, and also for timber, for construction, for firewood and various other things. So the actual montane cloud forest now is only still around about 16 hectares in size, and it is pretty fragmented, but it is an amazing landscape. And as you can see just from this slide, we're looking up the central ridge of the peaks, National Conservation Area, and you can see how steep the topography is. This slide shows you some of the lower slopes, which have been taken over by the flax. And since the flax industry finished, the flax is very invasive, and it's actually taken over a lot of the land area that the endemic cloud forest would inhabit. And so the research projects that I've been working on with colleagues from the island and from outside of the island, we've been principally looking at how best to manage the habitat to try and increase the endemic cloud forest habitat further, and to actually restore it in areas where it would have naturally occurred and where the flax has invaded. This particular ridge we're looking at, if you follow the footpath to the top of the screen, you'd actually get to Halley's Mount, and that's where Sir Edmund Halley did his observations of the comet that is named after him. Okay, and this slide also just gives you an idea of the remoteness of the island. It's incredible when you're on the top of the peaks and you look all around you, 360 degrees, and you can actually see the curvature of the Earth. It's incredible. But this slide also gives you a really good feel for how the green heartland changes down into sort of a semi-desert fringes of the island where it's a lot drier. And if you can see in the central right of the photograph there, you will actually see St. Helena Airport, which is something I will come on to in a moment. So when I first worked on the island and lived there with my family, there was no airport. So how did we get there? Well, for many, many years, the island was serviced by the Royal Mail ship, St. Helena. It was an unusual ship in the fact that the front half was a cargo ship and the back half was a passenger ship. And the majority of people who were traveling on the ship were saints going back to see family and friends, or people who were working on the island, plus an occasional tourist. And there were two routes for getting to the island. The first one was flying from RAF Bryce Norton down to Ascension Island, and then picking up the Royal Mail ship once a month as it did a run from St. Helena up to Ascension and back. That voyage was around 2.5 days in length. But the more regular route went from Cape Town, and traveling from the UK, it would take you 7 days to get to St. Helena if you're traveling by ship, because you'd have to fly into Cape Town, stay overnight, and then get on the Royal Mail ship. Then it was another 5.5 days travel to get to St. Helena. Quite an amazing experience at the time, but clearly meant that goods, services, post, various supplies, etc., did take time to get to the island. And the ship used to go to the island roughly every 2.5 weeks. So this is the view you had from Cape Town as you left on the ship, an amazing thing. And then 5.5 days later, you'd get this view. We'd just see the island in the distance. Again, after 5.5 days of just sea, it was quite refreshing to see some land hoving into view. And then as you got nearer, you could see just how steep the cliffs are of the island. There are only a few valleys that will actually come down to sea level. This is one of the reasons why the British government actually effectively exiled Napoleon to the island, because it is pretty much a fortress island. There are a number of fortifications around the island, and they were there basically to block up any valleys that led down to the sea. And they had garrisons there that were keeping an eye out for any rescue parties for Napoleon. So the shipping service ran for a long time, but in 2011, UK government signed a contract to begin the construction of St Helena Airport, with a view that regular flights from would service the island and allow the island to grow an ecotourism economy, and also just to provide the islanders with a more secure connection to the outside world. So when the Royal Mail ship was operating, if someone was seriously ill in the hospital, couldn't actually deal with their ailment, you'd usually have to try and get another ship to come to the island to pick up the sick person and take them off, or you'd try and basically keep the person stable until the ship came and you could actually get them back to Cape Town. But by having an airport, you could medevac someone from the island back to the mainland within 12 hours. So, you know, there are huge, great social opportunities from having the airport, as well as economic opportunities. So when I arrived on the island in 2013, the airport construction was underway, and it included an incredibly huge basically valley fill project. It filled up a good chunk of dry gut, and the level was built up to create an extra length of runway, which was basically an escape route for the aircraft should they overshoot the runway a little bit. Here's another image of the control tower and the main terminal building being constructed. That was around about early 2015. And then in May 2016, the airport was certified for operation. Commercial flights started then in October 2017. Now, in between those periods, the Royal Mail ship kept operating while the flights from Johannesburg were being established. And we now have weekly flights from Johannesburg to the island, and then monthly flights going from St Helena up to Essential Island and back again. And it cuts down the journey to the island from the UK to around 2.5 days, which is incredible. But the airport opening did obviously mean that when the nature conservation partners were looking at drone technology for supporting habitat restoration work and water resource management work, that it basically meant that we're going to have to think quite hard about making sure that drone flying was safe. So that led me to working on the first Darwin Plus funded project, where we wanted to map a couple of small water catchments that were very significant for the island because they provided about 40% of the island's actual water. But they were also in the cloud forest, and we wanted to understand the link between cloud forest habitat that was predominantly made from endemic tree fern thicket, and then look at the amount of water that you'd get from the sister catchment that was predominantly had flax and invasive species on it. So when we were designing the project, we got in touch with Bruce Dancy at ASSI and with Gwyneth Howell at the airport to actually talk about how to fly the drones and to fly them safely, and to understand what systems and processes were in place. So this lovely diagram is something that was published around that time by the airport, because one or two people had started to fly personal drones on the island, and obviously with an airport operating there, significant safety measures needed to be taken, just as you would anywhere else in the world, to ensure that there weren't any problems with flying drones on the island and the operation of the airport. So we had this, the island was basically split into three. So we've got a safe fly zone, which is just around about half the island. We've got a restricted fly zone, and then we've got a no-fly zone. Now, for our research projects, the areas of interest were in the restricted fly zone. So we immediately needed to work out what we needed to do to be compliant with the airport and ASSI. So we went through the process of getting a pilot, myself, certified under PIFCO. We then submitted all the correct documentation to ASSI to allow us to fly on the island, and obviously to pass that through to the airport. And we were issued in 2016 with the first commercial license to fly a drone on the island. Obviously, being somewhere like that, we had fewer issues with commercial flights because the commercial flights were only planned for Saturdays. So that made life a lot easier. However, we did still need to consider the issue of medevac flights, which could occur at any time. And we were starting to find that private planes were beginning to be flown from the African continent across the island. And those would be obviously unscheduled flights from our perspective. So we, through the permission, came up with a system of works with the airport and with ASI so that we could basically submit flight plans and be compliant with the work we're doing. So, okay, so what were we doing when we were flying over there to start with? Well, the cloud forest surveys, what we wanted to do was to understand the proportions of habitat types in the cloud forest in the two catchments we were interested in. So as part of our project planning process, we actually had a chat and went out to site with the wonderful remote sensing team at the Royal Botanic Gardens Kew, who do a lot of habitat mapping around the world for project partners. And so they came down to Kew's Sussex base at Wakehurst Place. And we spent some time comparing different drone technologies, looking at the quadcopter that we were using and discussing the reasons why. And they had their fixed wing they brought down. And we spent some time basically effectively trying out everybody's equipment, talking about the pros and cons and understanding more about data processing, managing the data, outputs, and what we could expect quality-wise from the data sets we were going to get. When we got to the island, we took a DJI Phantom 4 with us. At the time, it was the most cost-effective and compact drone that we felt we could use on the island. And at the time, because it was the first time we'd used a drone for conservation habitat mapping, we wanted to keep it pretty easy. So we were limiting our surveys to effectively producing orthomosaics to help us with this habitat mapping process. So while we were there, we had several sessions of helping the local project staff get used to operating the drone, as shown in these photographs. We put together various flight plan documents for the airport and came up with a system of works with air traffic control so that when we were going to be flying in the restricted fly zone, we had these standard lines of communication. We would phone in when we got to site, we'd phone when we were ready to fly, would get clearance, and then we'd phone in again when we finished our operations and we were going again. And that was based upon flight plans that we'd submitted for each of the different surveys that we wanted to do. So as an output, very standard orthomosaic. This is going back a few years now for us, so it was really new and exciting. This is Weld's Gut, one of the main water catchments we were looking at, and it had predominantly tree fern thicket at the top part of the catchment. As you can see, there's some stats there. One of the key things that we discovered through that process was because the island's topography is so steep, our takeoff and landing area was decided to be at the top of the catchment, so we could actually have good visual line of sight of the drone. But what it meant was that we had the drone flying at 50 meters above the takeoff and landing area. But at the furthest distance from the drone, we actually had a drop of 184 meters, as illustrated in this diagram. So that instantly flagged up some issues from us with the quality of the images we were getting, because we would obviously get reduced quality, bigger pixels per square meter, less resolution the further we went away from the takeoff and landing area. But given the steep topography and the fact that we had to basically walk in every time to take the equipment in, we were limited in the duration we could fly for based on the batteries we had. Obviously, any airport considerations, but equally the climate, because despite the fact the island's subtropical, the montane cloud forest is where the island's water is generated. So when the cloud comes across, it actually covers the whole of that area in a fog, and water collects on the leaves, and that will eventually work its way into the water catchments as well as experiencing direct rainfall. So we'd spent a lot of time sitting up at the peaks waiting for a clear window of weather, and then we'd contact the airport to fly. Anyway, so we got some good images though, and as seen just from these two little cutout inserts, we actually found that the when you're zooming in on the orthomosaic, we actually got some pretty good detail. You can see in the top right-hand photograph there are two water tanks that are fed by springs and streams further up the catchment, which is at the top of the catchment is the bottom of the large left-hand image. And you can also see the in the bottom right-hand image, the takeoff and landing area from the orthomosaic when we zoom in. Outputs from that, though, we imported the imagery into QGIS. We had one of our project ecologists complete canopy surveys in parallel. So what they did was they'd go out, walk the catchments, actually make field observations of the different assemblages of plant species there, and then we'd come back and we'd use the orthomosaic to actually sort of map out and identify the areas covered by the different vegetation types. And off the back of all that work and a lot of climate and water resource data we collected, we came up with this figure, and the sort of the darker green area marked out here were proposed cloud forest restoration areas, where we'd been identifying the minimum level of the cloud base, looking at the historic record for where before the deforestation and the invasive species came in, where we knew the cloud forest went back down to. And we basically came up with around a 690 meter contour as being the lowest part of the island where you'd get these cloud forest plant assemblages occurring. So that's the first application for sort of some basic drone data. And it really unlocked a lot of opportunities for the island in looking at how we could use drones for environmental work. So the second example I've got is more recent. It's work we did last year. We've been working on another Darwin Plus funded research project, and that works dovetailing also into the FCDO funded cloud forest restoration project. And what we've been doing is we've been collecting more surface and groundwater level and flow data to understand the island's water resource and water availability. We're also looking at more climate data. So with the support of the UK Met Office, we've put in a network of automatic weather stations around the island and some other mist and rain monitoring equipment so we can better understand the island's climate. And we're linking all that together into what we understand about the island's geology and its hydrogeology, because some of the water that gets to the island will eventually recharge down into the aquifers. So we have done a number of geophysics surveys in the last few months to actually better understand the underlying geology. Geophysics was selected because it's a lot cheaper than drilling. Being so remote, actually getting the equipment to the island is incredibly expensive. So actually flying out and purchasing certain parts of the geophysics equipment portfolio was seen as the most cost-effective way of doing it. So where do drones come in? Well, the drones have helped us to collect a lot of aerial footage to actually better understand key areas that we've wanted to do our geophysics geological surveys in. This is Fisher's Valley, which is on the southern part of the island. It's the only wetland area on the island. And as you can see, sort of in the middle of the picture, just above the wetland where the Land Rover is, you've got a water tank, and there's actually a green cabinet next to that, which is a borehole, which is used for providing a groundwater supply during certain times of the year for the island. So we wanted to understand how the surface water and the groundwater interacted around the wetland, and to see how the ground conditions, i.e. the geology, what it looked like and how that influenced where the water went. So we flew the drones to take video. We produced a large orthomosaic, which we could use to take a look at the extents of the wetland. And what was great was it was for the first time allowed us to actually see where all the standing water was across the wetland area, because there's a very, very small stream channel running through it. But when there is a lot of rainfall recharge, it's difficult to see through the vegetation where the surface water table occurs in the wetland. So that was really helpful. What we've then done is that we've then produced a very coarse 3D model from the orthomosaic, just to give us a bit of a 3D visualization. And using some early geophysics results, we've been playing around with the 3D model and the geophysics 2D slice through the Earth. And we've been trying to come up with a bit more of a model that helps us understand about the ground conditions below that 3D surface. This is very, very early days. It's a very crude diagram, but we're working with project partners over the next few months to actually better visualize this data. And we're looking to see what other opportunities and packages there are out there for us to actually produce this slice of geology through the island and actually combine it with that 3D data so we can see and communicate better what we believe is going on in different water catchments around the island. So that's something that we're going to be working on more over the next few months. The third example I've got has been using drones for doing asset inspections. So it's something that will get done anywhere else in the world, but it does unlock obviously lots of opportunities. The government were looking at doing a survey of Jamestown waterfront, in particular looking at the structures, so the retaining wall, the sea walls, and the wharf area, and they were going to use that information to help overseas-based planners and structural engineers understand a little bit more about the context of the waterfront area and to do some inspection work remotely. So drones were used to again produce an orthomosaic and a 3D model, an elevation model, and that data was sent through to the structural engineers and to the planning teams and the architects. The data sets that were used were brilliant because people could zoom in on the orthomosaic to a great enough detail that you could actually look at certain main defects. So, for example, in this picture, just to the southeast of the shipping containers, you can see a rectangle of concrete roadway where there's a lot of damage there to the concrete. So that enabled overseas project partners to look at island infrastructure in a lot of detail, but without having to get people over to the island at great expense for effectively what might only be 2 or 3 days worth of work. And a final example of the kind of things the drones are being used at the minute is Horse Point landfill. So this is the island's only waste management facility. It is very close to the airport. So as part of the airport construction work, a lot of data was collected by colleagues of mine in the Environmental Management Division of St Helena Government to help support the design of bird strike mitigation measures. Because the airport was only around 2 miles away from the landfill, and the landfill couldn't be moved because the island has very little land area with soft enough ground that you could excavate cells for a landfill. So mitigation measures were identified, including the construction of a large waste reception building, which was envisaged to be used for leaving waste on waste collection days, having the waste closed off while flights landed and then took off, and then putting the waste into the open cell later. But as you can see in this image, a netting system was also used as well. And so in the open cell that was operating, a net was basically placed over there, and an excavator would bring the waste in and drop it in on a planned basis. However, the waste management team need to manage the site, and it's a very large area, and they want to understand where do we dig the next cell, what other opportunities are there for operating the site for waste management purposes. So with a special permission from ASSI and St Helena Airport, we were actually allowed last October to work in the no-fly zone on a particular day. As you can imagine, lots of paperwork involved, lots of safety measures involved, but the airport and ASSI were amazing in allowing the team to actually do some flights over about an 1.5 hour period. And we were collecting images, video, stills, orthomosaics, and these are being used by the waste management team to look at the facility back in the office, to use software to enable them to work out dimensions, distances, cuts and fills and things like that over time, and to plan the future management of the site. And here's the final orthomosaic on a bit of a zoom in there. So what does that mean for drone flying sort of in the future for the island? Well, so far we've used very basic consumer drones. So the environment team, the conservation team certainly in the government have had a DJI Phantom 3. They've got a DJI Phantom 4. They're looking at getting a Mavic 3 in the future now. We've also been using Phantom 4 Advance and DJI Air 2S and a Mavic Pro. So a right mix of drones. Image resolution wise, it's been improving over time. But what other applications can we use it for? Well, one of the first things that we're looking at doing with the local conservation teams is for them to start using their drone on a more regular basis to monitor change. So this is an example slide of about another 4 I've got for you that were provided to me by colleagues we're working with at the Centre for Ecology and Hydrology, just to illustrate applications for drone use for habitat management. So this particular one just gives you a series of images over time of a pond and how the pond has basically gone from being newly created to being a fully flourishing habitat. Now, what we would love to see on the island is working within the challenging topography of the peaks is to gradually get pilot confidence to fly on a more regular basis with the support of the airport. So we can take maybe 6 monthly or annual photo montages of the restoration areas. And then they again can be used to see success, to quantify work done and to help plan a following year's worth of cloud forest restoration work. Another application that is really interesting would be in the future to use AI in a more sort of consumer friendly basis to actually do plant species identification and counts. I know we can use some drone softwares at the minute to do some forestry tree counting. That's not an appropriate application for St. Helena because of the variety of species in there. But this is something that colleagues are keeping a close eye on. And it will be amazing over the next 5 years if that technology could trickle down to kind of a more cost-effective use by everybody to enable us to do this work. We've also got an opportunity with the AI to use neural net deep learning, again, to do counts, but potentially to use in color, for example. One application that's shown here has been for informing plant pollinator studies to work out where those plant pollinators, the pollinator plants are. I have another example here where actually you can look at the invasive species control. So we have invasive species on St. Helena in the cloud forest, and they're causing quite a problem at the moment. And one of the opportunities will be to use drone mapping in the future to help us monitor the spread of invasive species and, again, to plan mitigation measures using that information. Also, we haven't, the new drone that the team would like to get will have an NDVI camera to do normalized difference vegetation index work. That's something that we haven't done so far. The drones that we have can give you a pseudo image, but it's not a reliable image, so we've left that to one side. But that would be really helpful, again, to look at the health of vegetation across the conservation areas we're managing. And then going back to infestations and diseases, we've looked at plant disease, but actually there is research that's been done over the last few years now, which has begun to look at tree damage from bark beetles. And so you can identify the signature of the damage in the tree and then, again, use your mapping information to work out where those areas are and how they're spreading. So to conclude, these techniques will be amazing. We need to effectively give the team the times to actually plan and to look at using these different techniques in the future. But drones have started to be quite a powerful tool for conservation work on the island, and I can only think that they'll be used more as we go on within the constrained confines of the areas that they need to work in the operation of the airport. So kind of the final conclusions I've really got for this are the drone use on the island has been great for habitat mapping, for looking at assets, for monitoring change, and for planning field work. And actually, there's another one we've got down here, which I think is even more important for such a remote island, and that is it enables us to help visualize the island for people who may be supporting projects from overseas. And we can actually provide some really good quality imagery and video to help quantify and show the site areas that we're working in. Yeah, it's low cost at the moment. It's a really great tool, but we just need to bear in mind, like everywhere else in the world, we have an operational airport. It's incredibly close to most of the places that we want to work in. So we need to have the right training, the right permissions in place to enable us to do our work. So there we go. Has anybody got any questions?
I certainly do. That was fascinating. Thank you, Ben. Really interesting. It's an island I've had a lot of interest in over the years. So one of the things that really sort of I was really curious about was what happens if something goes wrong with your equipment in particular, because as you mentioned, you're so distant from South Africa, from other airports now, I guess, as well, that actually you can't necessarily be reliant on people there locally to be able to source you a new drone. How do you cope with those issues?
Through a great learning exercise I had on the island, it's making sure you do actually have 2 drones. So that's the first one, having a backup, and that is a very expensive option. One of the times I was flying and we did lose a drone in the peaks. We thankfully had the second drone, which was identical to the first one that was being used by the project team locally, so we could continue with our work there. But what I do now always, if I'm taking a drone to somewhere so remote, I will actually take a smaller one. That's partly why I got an Air 2S to go with a bigger drone, just so we had the backup. It sounds like a crazy thing to say. Yes, we can take spare parts. There's no doubt about that. But if something major goes wrong with the drone, and it's taking you several days to get to your site to work on it, if you try and order a replacement part, it's not going to get back to you in 24 hours. You're likely to get it back in. The earliest is perhaps 2 weeks. So, you know, if you're only there for a short period of time, you have to have a backup plan. So yes, lots of spare props, plenty of batteries, spare charger systems, all that's absolutely fine. In the worst case scenario, actually take another drone with you as well.
Yeah, sure. And again, one of the other things I would ask, what's the internet like? What sort of facilities have you got that sort of for your connectivity side of things, particularly as you mentioned, sort of the ability to be able to take images, record images for people who are working elsewhere on projects on the island? What happens?
Yeah, it's a really good point. So when I was living on the island between 2013 and 2015, the island was still without a mobile phone network. So again, operating a drone, you needed to make sure on planet everything was offline because you had no other means of communicating for mapping and stuff. We had a satellite uplink on the island, which is still operating, but to provide the island population with internet, it was incredibly expensive, and at the moment it still is. And we had about a 1.5 megabit connection speed. So with the having cloud-based mapping software wasn't really an option. So the first time we were working on the island and doing the mapping, we had to do the flights and then just rely on the fact that we felt professionally that the flights had worked well and that we got enough data. And then we'd have to wait 6 weeks until we got back to the mainland to then upload the data onto the cloud service provider and actually get the mapping imagery out. So that was an issue. What happened about 18 months, 2 years ago now is St. Helena government and the UK government have been able to fund an interconnect with a new undersea fibre optic cable that's going from the west coast of Africa to the east coast of South America. So that interconnect has now made landfall at Rupert's Bay on St. Helena, and there are lots of things going on the island at the minute to actually get the island connected up to gigabit Ethernet in hopefully the next sort of 18 months time. So at that point, it will be a lot less of an issue because you'll have what you would expect from a mainland internet connection. 2016, mobile phones arrived, which is amazing. So that's been really helpful, especially when contacting air traffic control, for example, and actually talking about starting and finishing flights, all those basic things you don't think of on the mainland. But when it came down to data processing, one thing that we've done over the last 2 years is with the advent of the really, really fast mobile chips that Apple have brought out for their MacBooks, the MacBook Pros especially, we've actually been using OpenDroneMap, Web ODPM. I'm running that on an M1 MacBook Pro, and we can actually process 400 images into an ortho mosaic in about 20 minutes offline. So, you know, there are some solutions around. There are obviously other solutions that will give you a better quality image, but if you want to get back from site one day, have a look at what you've done that day. Is it good enough for us to do some more processing on that data when we get back to the mainland? Then that's been a solution that's been working really well for us.
Yeah, exactly. It would be, I could imagine it would be extremely frustrating to get back to the mainland and then realize actually it wasn't good enough and you had to go back again.
An incredibly costly process. Yeah.
Exactly.
So, and the other thing I would just say is back up your files.
Yes.
I'd always have at least 3 copies of the data in those situations with me.
Yeah. Indeed. And you mentioned the airport being built, and it looked fascinating. So it must have been great, sort of from an aviation background, sort of seeing that going up. Were they extremely open to you to discussing sort of how to go about setting up permissions?
Absolutely. I mean, when we actually first approached the airport, they were in the process of getting certified and opening. We said, what we want to do is this. And they went, well, actually, we actually don't have a formal process in place yet, but we're going to do one. So they'd already been looking at people flying local drones and going, well, we need to do something. So that's why that map and there's a lot of hard work went into getting that done, was put together with the support of ASI. The next step was really going, okay, with the team at ASI in Crawley in Sussex, it was just to understand, well, okay, what would be appropriate for the UK? We obviously need to make, the island is obviously internationally certified, there's international law to comply with. Because it's a British overseas territory, Air Safety Support International are responsible for regulating the airspace with the airport. So the team basically pulled together a methodology that they had been operating elsewhere and basically tailored it for the island.
Great.
But yeah, they're all great.
But amazing to be there sort of as they get that up and going. Were you the first by any chance?
We were the first to fly under a commercial license. So people have flown drones on the island before us for personal use. But obviously once the airport was opened and it had its regulated airspace, then yes, absolutely. We were the first to do it. Excellent.
Well, it's always good to know that there are professional, responsible people out there driving and building on that reputation of professional drone operators. Thank you. That's great.
Thank you.
what happens about, so again, sort of building on that sort of airspace use side of things and working with airports and that sort of side of things. You mentioned that you had a flyaway at one point and it crashed. What happens in terms of accidents? I'm assuming there is something sort of built into the process in terms of reporting stuff there.
Yeah, okay, it wasn't a flyaway. What happens? No, that's fine. No, it's fine. No, what we had, what had happened was basically we got hit by wind shear. That was ultimately it, and that's one of the reasons why the airport is operated the way it is, because there are some very strong winds that do come across the island, and we had been flying from the highest point of our flight plan for several flights, and thought it would be worthwhile basically seeing if we could get better resolution for the lower parts of the areas that we were mapping. Because I said to you earlier in the talk, we had this sort of 180 odd meters difference in elevation between the top part of the site and the bottom part of the site, just because of the steep topography. And yeah, and we were flying from a lower point up, and unfortunately we had this squall came through, and it just pushed the drone straight into the flags. So what happened then? Air accident report process. So as part of all the systems and processes that ASIA put in with the airport, we contacted the airport immediately, and ATC explained what had happened, and then submitted an accident report form. Now, at the time this happened, I should say, we were flying under a permission. There were no flights, and we had clearance from air traffic control. So we had everything in place. Yeah, it was, unfortunately, it happened.
Exactly. Sometimes things do happen that is just outside of your control. Yeah, indeed. But again, sort of having a good working relationship with the airport and ATC must have been a benefit.
Several years after that happening, every time I travel back to the island and walk through the airport and see colleagues there, I always get ribbed about it.
I bet. Great. So please, I know, sorry, I've been hogging you in terms of questions. Please do feel free, everyone who's watching, to add questions, because this is why we're here, to explore and find out and learn more. I find this absolutely fascinating. I think it's a really interesting island, and I actually had to look up what a cloud forest was to start with. Because it wasn't terminology that I'd come across before. So fascinating, sort of making us all learn much more. And great that you were able to take drones in and show all the different use cases that you can put them to.
Yeah,
really good. So has anyone got any questions? If not, then I'm very happy to bring us to a close, but please do, this is absolutely your opportunity to do so. And while you're thinking of those and typing them up, I will just let you know about other upcoming webinars that we have in the next few weeks as well. We have on the 4th of May, integration of UAVs and remote sensing in ecological consultancy. I think this one is much more sort of UK focused with Traxicology. And at the beginning of June, we have UAS and agriculture, including spraying and spreading with auto-spray solutions. Again, another excellent session coming up, particularly given that the spraying and spreading side of things is very much a very new area for UAS, and at least in the UK. So we're delighted that we will be hearing from Auto-Spray Solutions for that. I think at the moment we have no other further questions coming through at the moment. What I will do is that after the session, when we've uploaded the recording to the website, I will email this out to everyone with your details, if that's okay, Ben. Brilliant.
That's fine.
Email address, so that if anybody does have any further questions, they can get in touch with you.
That's great.
So thank you very much. What an amazing projects to be involved with. I'm delighted to see all of this, and I think it's great that you've been able to give us your time and share this information and knowledge with us. Thank you.
Thank you very much. It's been great talking about it.
Okay. Well, thank you very much as well, also to our attendees, and look forward to seeing people again at our next session. Okay. Thank you very much then, everyone.
Take care. Bye.